am Lori Clapper, editor with Pharmaceutical Online here at INTERPHEX 2012, talking inspection with Oliver Stauffer from PTI. Oliver, thanks so much for taking time out of your show.
Thanks for joining me.
Now, I want to start out with talking about the status quo in the inspection business. What has that been?
Well, for blister packaging, one of the most common leak test methods, the blue dye inspection method, is very widely used. It's grandfathered into most sites, and oftentimes you'll find that it's not validated for most blister package formats. It's a method that has its issues. It's subjective, it varies from package to package, and it's not sensitive to the leak test requirements of most package formats. So there are a variety of issues that are associated with it, and aside from that, it's subjective. It's an attribute, a result, it's not quantitative. And with USP 1207 being rewritten, more precise and quantitative methods are required. And that's where you have other leak test methods, such as a non-destructive quantitative approach to leak testing blister packages. And that's really the way the industry is shifting, and it's something that really improves the process and quality of the package.
How about vial inspection? How have you changed inspection processes through your solutions?
So for vial leak testing, vial, ampule, and pre-filled syringes, the blue dye leak test method is very widely used. There was a PTI journal article that a year or two ago that compared the blue dye leak test method to vacuum decay approaches and showed that the blue dye leak test method is greatly flawed, has a lot of issues with the subjectivity, and quantitative methods are a much more reliable approach compared to the subjective methods. But when we look at vacuum decay as a solution for parenterals, you have to think about the product and what's the content of it. And so if it's a large molecule or a protein, vacuum decay and most of these methods that require something to enter into the package or outgas from the package will not work. A protein and a large molecule will crystallize in a defect very quickly, and that's where you need something like high voltage leak detection. And that's one of the only technologies that doesn't rely on anything to enter into the package or exit from the package. So if you have a protein or a large molecule crystallizing in the defect, the high voltage leak detection will still detect it. And that's something that's really unique about that technology.
Now, if you could give a couple of reasons to a manufacturer to switch to your method, what would those be?
Well, certainly just the fact that using a quantitative method is far more reliable, and when doing any kind of leak test, when relying or needing accurate information, accuracy is actually a subsect of precision. If you don't have precision, you will never be accurate in the information that you're providing. And that's where having a quantitative method that's precise and reliable and repeatable can give you accurate information. And that's what's greatly misjudged in the industry. Just because a blue dye says it's pass or fail, is it accurate? Is it testing down to the leak size that you actually need? So that's one main reason. And the fact that it's non-destructive allows you to reuse those packages, do further tests on those packages. If it's a class 2 regulated drug, you no longer need to throw it out. It's a much, the cost of throwing away product is also a great justification for moving to something non-destructive. So,
thank you so much for that information.
Thanks for having me.